Oh, Tay, where'd you go?
This week on Lift Art Builds, we start this custom swing set. It's gonna be huge! Can someone help me down?
Nope.
Okay. Good luck with the episode. What's going on, everybody? Welcome back to the shop. Today I've got a special project that I'm working on. It's actually a custom swing set for my cousin who lives down in Charlotte, North Carolina. So on the screen you can see the rendering I've got worked up so far. It's all going to be built out of 2-inch square tubing and 1.25 inch round tubing. 12-foot span, 8-foot high, and it's going to be stuck in the ground in the four corners with 2-foot long stakes. So she's already given me the deposit for this. I've got the material here already from the steel supplier, so I'm ready to get started. And I was just double checking all my dimensions and everything, but this is gonna be a cool build. She's given me permission to put this on the channel. Lucky for you, I get to bring you with me. And when we finish it and paint it, we'll be able to truck it down to her, install it, and get some real-time feedback from her kids to see if we did a good job or not. But without further ado, I think we'll get out there, start measuring some steel and cutting. So here we go. So we got our plan, and the steel's over there. So I can't put 24-foot sticks all the way back to the chop saw. So what I'm gonna do is cut them to length here on the big Johnson, and then take them back there and cut the miters on them. Okay, so we got all of our lengths cut, rough cut. These two are the 12-footers that's gonna make up the cross ladder. And those four are the 8-foot 8-footers that are gonna make up the sides of the A-frame. And then these 2-foot connectors up top, I'm gonna cut out of this piece, which was left over. So raw material is now in manageable lengths and close to the right shape. I just got to cut my miters and stuff. So I got to do some math, figure out some angles, and get these stickers off. Why do they put stickers on here? I know what it is. I don't need a sticker to tell me what it is. There's so much. It's so terrible. Could be a bigger problem, obviously. It's a pretty small problem. Just don't like stickers. So what I'm doing basically, I know the interior angle of this because I measured it in SketchUp. So when I'm trying to figure out the cut to make on the end of the pieces, I think this is right. Double check, because I can. I'm gonna go double check in the software. But I wanted to do it by hand first, just to, you know, explore that part of my brain again. And I'm gonna go check my work because I can. So let's go see. What I'm working through is this angle here. Let's pretend that we have, I'm gonna put in that as a cut. So that represents the miter. And now I'm gonna take the protractor tool, I'm gonna put it here, put one there, put one there. My answer down the right corner is 124.7, and my answer in real life was 124.7. I am so happy that math works. Gosh, that's awesome. All right, little confidence booster, and I will keep going. This is why I love 3D modeling, because you can check things in real time and you can navigate the model before you waste any material. Now, that doesn't eliminate all possibility for mistakes, but at least If I build it and cut it the way it is in the computer, it's gonna look exactly like that. Except it's not gonna be white, obviously. Neat. So the way I'm gonna do this is I have this rad tool that I got at Home Depot. It's a Husky thing. But as you move this, it tells you the angle, as long as you zero it on a flat surface. So, theoretically, I'm just curious. If I set this to 124.7, now if I lay this here, and then if I go right to the corner, like that, and scribe, so there's my angle. I'm listening to music because I like music. So you're not gonna be able to use any of the audio from this because copyright infringement. Okay, so as you saw, I was able to cut all those angles pretty quickly once I had the saw locked in. You know, you lock the saw at the angle and then you don't have to think about it anymore. Then you just cut off as little as possible. So now I'm gonna take that leftover piece over there and cut the two top connecting deals. Now those are gonna be pretty easy too because they have a miter on each end. So I can cut them to length and cut the miters at the same time by leaving the saw over there. And I'll show you how to do that. Pretty sure it's gonna die, but this is the end of the day. Got everything laid up on the jig table. Things are happy, clamps and things are in place. Pick it up tomorrow. So last night we left off, I had cut the A-frames and got the top miters figured out. So we got it all laid on the table, we got it clamped up, and we got these are all hard attached to the table. So we'll be able to pull this out and set it back in there and this angle will be perfect, which is important because we need to, excuse me, we need to make a cut here. You know, so this is the bottom of the leg and the ground is actually this plane. So I need to make a miter cut on the bottom of all these legs, which means I got to pull them out of here and then be able to put them back in to weld them. So now that all these stops and clamps and everything are in place, I can pull these pieces out, put them right back in. I don't have to think about angles and I can just weld it up. So that's what I'm gonna do. Yoink. All right, I'm gonna cut the other two. Unrelated. Ooh. Finally getting around to putting a top coat on this conference table top. See, I told you it would be featured in a future video. Back on the swing set. It's out here. Left off, welding the first A-frame in place and fitting the cross tube. In classic form, it's already 2:45. I've had a day already just taking care of stuff, but we're gonna stay on this for long as I can today because I definitely need to get this one off the table. So let's go. A-frames are welded together. I got the top rung in, so now I just got to do the next two rungs. And I'm just going to repeat the process I did for the top one, which is cut the angle on one end of the pipe, measured from long side of one miter to long side of the other miter. And yeah, and then I'll set the stop up like I did so that the second one I cut at the same size will be the same size. But yeah, we're gonna keep going. Yeah. I think I actually found a piece. So what this is actually schedule 40 pipe. And the only reason that's relevant is pipe is measured on the ID or inside dimension, whereas tubing is measured on the outside. And you can usually tell, so this is 1 inch pipe. So the inside dimension is exactly 1 inch. Whereas this is 2 inch tubing, and it's exactly 2 inches on the outside. So pipe versus tube is relevant because here it's like 1 inch and 5/16 basically outside. So this is threaded, you know, you see schedule 40 metal pipe, and I think this is it. So I'll have to cut the threads off, obviously. But it looks like the outside dimension is about right. It's hard to say. I think it's all right. I'm gonna cut the threads off of one end so that I can get a better measurement of it, but let's see. All right, got lucky. Found the right pipe, cut 2 more pieces. This is a mill scale coating, the stuff I got. And this is some sort of matte oxide coating. I don't know, who cares? It's all gonna get painted, so it may look different now, but it's not gonna matter down the road. So I'm gonna deburr the edges, grind this sticker off, and start laying things out. Okay, so here's where we're at. We got the top piece built, mostly. It's all welded up and it's square, so that's good. Thank you, fixture table. And we got the A-frames welded up. They're not ground flat or anything. It's just everything is rough fabrication stage. So now we got to figure out how to join these. And you know, there's a few thoughts I've had. Matching plates with holes in them that can be bolted together like flanges. Or one thought I think I'm gonna do is basically weld a plate in here that has a hole in it. And through that hole will be a bolt that's welded on the back side of that plate. So you'll basically have a flat metal surface with a stud sticking out the middle of it. That would then correspond to a hole that I drill here all the way through. So the stud on the end of that ladder piece goes through the top corner of the A-frame, and then you put a big fat bolt on the other side. I think that would work, but I'm not 100% sure that the thing's not gonna rack. So I might have to do that, and then also some gussets or something that go up and over, some sort of triangular gusset. That's all pretty easy, but what I think I'm gonna do is do the stud bolt method first and get it assembled to where it's standing on its own and tighten everything down to see how it feels, and then I can always add the gussets later. This, I believe, will be welded to the back of that plate, stick out, go through there, and then put a nut on the back side. So I think that's gonna work quite well. So let's do that. So my critical measurements are 1.725, 0.75. The hole for the plate should be 0.625. I mean, that's 5/8. So we're gonna go in here to in route and do a little drawing. Make these plates real quick. 1.75 by 1.75. That's pretty much what I measured out there. See, the bolt is 0.625. So if we do 0.65, which half of that would be 0.325, then that should be it. 0.65. Yeah, 0.62. That should be plenty of space. So then we delete these guidelines, and that's the part I need. So now we'll go over here and merge it, which basically turns all the lines into curves, and then do our array command again. And there you go. So now we assign our tool paths. So we're going to be cutting this out of 1/4-inch steel. 85 amp shielded consumables out of 1/4-inch steel is 0.073. So then we'll go ahead and double check all our entry and exits. Everything looks fine, and I think we're good to go. All right, let's sync it up and go for it. task to do by myself, but that is a giant swing set. Man, I love having a forklift. Look at that. Cranked it up to the ceiling. Got my plates welded on. Looking good, feeling good. Just got to weld on the attachment points for the swings, which I got to figure that out. And we're done.